Today we're going to talk about how to use Desmos calculator to help us find the line of best fit. So when you go to desmos.com, you can just hit graphing calculator. You can be signed in for it to save your work. This little button here will actually allow you to download any graphs that you make. You can export image, pick the way you want it to look, and then download as a PNG, and that can be put into a document. The wrench is to help you adjust any grid lines. If you click and take away, you can see what those do. You can also add labels here and adjust the scale where it starts on the axis and by how much it's counting up. The plus is to zoom in, and the minus, of course, is to zoom out. If you get something really crazy and need to get back to the regular, just default back on the little home button. We're going to be adding a table of values with a scatter plot. So to get to a table, we're going to hit the plus and a table. Notice that the table has X1 and Y1. That just means it's our first table in here. If you hold down on the color, you can change the color, the type of little points that show up, and if you click the little lines button, it will actually connect those lines. We're just going to use them with regular points because we're doing a scatter plot. So I'll show you that if I add another table to this, we'll see this is X2 and Y2. So we're only dealing with one at a time, but those are important when you're working in Desmos to be able to tell Desmos what values you're actually talking about. So we have an example here where the table below shows a temperature and corresponding number of chirps per minute. So we've got a temperature outside and the chirps of a bird per minute, and we're going to make a trend line or a line of best fit to help us do some predictions about how much they would chirp at certain degrees or what the degree would be at a certain number of minutes. So I've already put our data in for us, and if I were to be at the home and when I put that in, I don't see any of the dots. So I want to make sure that I can actually see them. I can squeeze out, I can zoom in, zoom over, whatever I need to do so I can kind of see. So when I see those dots plotted, I can see they're going pretty much in a positive trend. And it looks pretty linear. There's nothing, it does have a little curve, but I could probably make a line of best fit go through that. So normally what we have to do is find 2 points, find slope, find the Y-intercept, and then it's a lot of extra work. So this does a lot for us. So we know that our line of best fit is the same as a slope-intercept form, which is y equals mx plus b. Now notice when I put this in, I have a error, like a warning, like something's wrong. Too many variables. I've got to tell Desmos what I want to use. I actually want to use this data table. So I'm using Y1 and X1. So beside the Y, I'm putting a little 1 and it drops it down. And beside the X, I'm putting a little 1 and it drops it down. Now notice now I've got all kinds of warning signs. And it's because this equal sign. I cannot say it's equal. I'm predicting. So that's an approximate. So I've got to get rid of that equal, and I'm actually going to put a little tilde. And it looks like a squiggly, and there's 2 ways to get to it. You can click the show keyboard here, and under the ABC, it's a little squiggly, one little squiggly. It looks like a squiggly line. You can also get to it on your keyboard. It's the button right under your escape key. Now notice when I plug it in, it's now going through these points, and it's got a line of best fit. So this is my line of best fit. The nice thing is it tells me how strong this relationship is. That's what the R means. The R is actually how strong the correlation is. And correlation is between -1 and 1. And we never want it to be 0. The closer it gets to 0, it's not a good relationship. It's very scattered out. Where the closer it is to 1, that means it's stronger. The positive just means it's going positive, and the negative means it's going in a negative direction. So this is a very strong correlation. We got 0.96. It's pretty strong, almost a perfectly straight line. So pretty tight correlation. That means that the temperature has a direct correlation on how many chirps the bird is chirping per minute. So now what it gives us down here is it actually gives us the slope and it gives us the y-intercept. So if we type this in now, y equals, and I'm just going to go to the nearest hundredth, 0.22x minus 0.33, I now notice that I have that green line right over my blue line. If I click that away and back, you can see it's exactly the same line. So now this is my line of best fit. Didn't have to do a whole lot of work for that, and it found it for me. Now I'm going to use it to predict what will happen. So if I know that this is my trend line or my line of best fit, and I want to predict the average number of chirps, and chirps are my X value, when the temperature is something, I want to know what the chirps would be. So the chirps are my y. So I want to know what y would be when my x is 50 degrees. So I can not put in y equals, I'll just put in 0.22, and for my x, I'm plugging in 50 minus 0.33, and that means that I'll have roughly 10.67 chirps per minute when the temperature is 50 degrees. Bird's a little cold, he's not chirping very much. Now, what if I want to know the approximate temperature when the bird chirps 14? Well, 14 would be my y, so if I put this in the same way, I'm going to change this back. We'll get rid of this here, and I want to know what it would be. Well, if I have my 0.22 x minus 0.33. Notice I'm not putting the y. And then over here I put my y equals, and I do 14. Where they hit is going to give me my temperature. So notice where they hit. So where they hit when I put in 14 was 64.9, so roughly 65 degrees. Now, we're going to do another example, and this example has to do with years. There's a little bit something different you have to do when you're talking about years in a table. If you put in the years as 2006, they have no idea. Desmos is going to take it as 2006, not the year 2006. So we have to look at this, and we have to know that this is horizontal. We know this is our x, and this is our y. And then when we think about our 2006, this is the beginning. So this is our 0 year. And then as we move up, that means 6 would be our 0, 7 would be our 1, 8 would be 2, 9 would be 3, 10 would be 4, 11 would be 5, and then 12 would be 6, and 13 would be 7. So when we put in our data, we're actually putting in 0, 1, 2, 3, 4, 5, 6, 7 for our x, and then our numbers. And this is average cost per gallon. So you have to be careful when you're doing years, and if it doesn't go in sequential and it skips something, if 2007 and 8 weren't here and it was 2006 to 2009, it would be 0, then 3, 4, and so forth. So let's put that data in our graph. So we're going to, and I'm not going to erase my little tilde mark here, my little equation line. I'm going to leave it, but I am going to erase all the data. So we're going to get rid of that, and we're going to put a new one in. So we're doing add, table, and now notice it says x2. Well, we're going to change it back to 1 because we're still working with the first one. And it'll make this go away, but we're going to put in our data. So we're doing 0, 1, 2, 3, 4, 5, 6, 7, and put in our gallons. 2.58, 2.81, 3.26, 2.35, 2.78, 3.53, 3.64, and 3.53. Now we see how clustered our little dots are here. But we can see pretty easily, because we left our little tilde here, it automatically made our line of best fit for us. So we can see that this is a positive correlation. They're a little bit more scattered away from the line, so maybe it's not as strong. So let's look at what our R says. Our R says that we are 0.71. So it is positive because that's a positive number, but it's definitely not as strong as that 0.9 was. So it's a little bit weaker. That's why they're a little bit more scattered out. But now here we have our equation. We have our slope and we have our y-intercept. So I'm going to go ahead and put it in. Y equals 0.14, and I'm just rounding to the nearest hundredth, x plus 2.56. So now we see our equation. And if we want to predict, this one says, use the equation to predict the cost of gas in 2025. We have to think about what year is 2025. Remember, on our data, we started 2006 as 0. So we got to count up to 225. So that would actually be the year 19. So we're going to put in the year 19 for our x. So 0.14 times 19 plus 2.56, and our average price per gallon of gas will be $5.22, which, whoo, that's expensive. So we can also, for this, it will allow us to put our table for, we can add a spot and do 19 here. It won't give us anything because we do not have our equation up here. So don't try to add it to the table to get it to work. You're going to have to use your equation and then plug it in and find the value.